Hi, this is Vivek from Ibot Club of IIT Madras. This video is a continuation of Vision series, and today we are going to learn about the rest of part of image processing, which is denoising and how to implement in robotics. So let's get started. Before studying about denoising, let us get a clear idea about what is noise. Noise refers to the random variation of brightness or color information usually caused by limitation in the image capturing process or transmission. It appears as a grainy, speckled, and distorted pixel over the image. Here are the various types of noises which we can find. So to tackle the following issues, we use denoising. The first method which we use in denoising is bilateral filter. We can get the analogy of how it's being implemented by comparing it with Gaussian blur, where it considers the color similarity as another parameter to get the best output. This similarity helps in smoothing of the image. So here is a demo of bilateral filter on my PC. So we are supposed to convert this noisy image of a cute dog into like a little more smoothened image. So here have written the code for it, and I would be explaining you. So the main function which is useful in this case is the bilateral filter function, which is predefined in the CV2 library. So what I'm doing is like the parameters which I'm taking is the image which is I'm reading from noisy.jpg, d equal to 9, sigma color and sigma space determines how do we approximate the smoothing based on the nearby pixels. So d equal to 9 is the diameter about the pixel about which the pixels would be influencing its change of color or smoothing. So let's see whether it works or not. So as you can see, this is the original one and this is the denoised one. So you can see that there is a lot of smoothing going on, and it is like a very good result, a very good result after like applying bilateral filter on it. So yeah, this works. Another method used for denoising is non-linear means denoising. It is different from bilateral filter in the way that it compares similar patches across the image, not only the nearby pixels. It is great for feature-rich images and natural look smoothing. So here is a quick implementation of code for non-local means denoising, and I would be doing a side-by-side comparison also. So I have a very like noisy image, so I need to smoothen the image and get the like smoothened output. So let's see what I've done. So I have used a function known as fast NL means denoising colored and the parameters as you can see. So non-local means denoising works on the basis of patches. So it has a predefined patch size which is defined by template window size equal to 7, and it is similar to a kernel, and it searches for through all of nearby size of 21 pixels to find the similar patch, and then it pastes it over it. So it is like computationally very efficient, and let's see how it works. So here is the non-local means denoising. As you can see, the original is very noisy image, but the NL means has done a pretty good job in denoising. We can use some extra filters and all to get a better version, but like only based on NL means denoising we are able to get a very like smoothened image and all. If we compare the same using denoising using bilateral filter, then let's see what kind of output we get. So here is the same image. So as you can see, like it's still very noisy and all, it is not working very much properly as compared to that dog image. So we can say that like non-linear means is in that cases like where the texture is smooth is very specifically very useful. Thank you. So the final step in image processing is called morphing. So it is generally used to process and refine binary masks or shapes by using simple operations that manipulates the image based on the structure. It is done using 4 methods, namely erosion, dilation, opening, and closing. So here is a very good example which I found in the internet which explains all of the process. The first one is erosion, which shrinks the white region in the binary image. Next is dilation, which expands the white region in the binary image. Third one is opening, which removes small white parts and preserves the longer objects. As you can see that like the rounded other end of the open O in the open is like invisible in the opening part. So, and the final is closing, which fills the small black holes. Now, as we have learned about all the steps included in image processing, we are going to build a object detector based on color from scratch. Here is a flowchart showing how which of the steps we should be following to achieve so. Let's have a look. First of all, we are going to take the video feed from our webcam. Then we are going to convert this BGR image to HSV, which stands for hue saturation value. Then we define the color range in SSV, depending upon the what color of object we are going to detect. For our case, we would be working with blue and yellow. So then we create a binary mask of this range of defined color to detect the colored objects properly. Then we clean up the image using morphological operations. Then we define the contours in the mask for getting the edges. Then we filter the area and drawing boundary lines to get the boundary rectangle of the object. And finally we display the output. So this is the steps we are going to follow to achieve the following. So let's move to our computer screen to see the implementation. Let's get started. So here we are in our computer screen, and I have written a code to detect this yellow object. So main motive of our video is to like detect this yellow bottle which I have. So it is like fairly yellow in color, so it should be like able to detect. So let me walk through the code which I've written. So first we are importing numpy and cv2. Then we are like using the video capture function to take a video input from our webcam. Then we are defining something known as HSV values for yellow color, and we can't point out a particular yellow color. We have to define a range up between which we will be like filtering out and like identifying whether the box is yellow or something. So for here we have some predefined values of intensity for RGB or HSV values. So which is 20, 100 and 100 for lower one, and for upper one is 30 to 55 to 55. So then we are taking the frame, flipping the frame and then converting the BGR format of image to HSV format, which is a very crucial step to show. So then we are checking whether it is in range of the yellow and lower and upper yellow by using enrich function and converting making a mask out of it. Then we are defining a kernel here, so that this kernel will move over the uh, frame and like smoothen out, which is morphing the image to get a clearer result. Then we would be defining contours which are for edge detection and for dynamic motion of the rectangle, so that depending upon the shape of the shape or size of the object, it would be dynamically adjusting to get a better result. So our this object is very big, our macro, so we can say that we can define the pixel like requirement for it to be like a pretty comparatively pretty large. So here for in CNT, like this CNT is the it will this for loop, it would be like moving around the defined contours which are the edges, and this area function defines the contour area. And then we are defining xyz edge to get the rectangle dimensions, where xy is the starting diagonal and x plus w y plus h is the ending diagonal point, so we get the complete rectangle for it. So all of this thing would be processed in the backend for by the predefined functions, and we don't need to worry about it. So, and finally we would be printing the means giving the output of that. So I've given one typo here because I was testing for green last time. So currently we are and finally we can capitalize. So let us see whether it would be working or not. So I have run the code, so he can see the computer. So as we bring it this yellow bottle, so it is able to detect the yellow object, and it is showing a text over it because wait. it is showing a text because here I have written to display a yellow object over it. So it is fairly working, as you can see. Wait. Yeah, you can see that here the yellow object detection is there. So if you bring my phone here, it is not detecting because it's black in color, and if we bring my blue bag here, it's still not detecting. So this is because it is defined for a predefined range of colors or hue saturation values, which is only suitable for yellow. So let's send the function and now check whether it works for blue or not. So I have for various defined colors, I have the numpy array for hue saturation values. So here I have blue for blue. So let us see whether it works or not. So we just need to substitute these values depending upon the color, and which is the upper range for that is 140 to 55 to 55. Just copy and paste it there, and then let's name it to a blue object. So most probably it would be also detecting my t-shirt. Sadly, I wore a blue t-shirt today, so I can't do anything about it right now. So let us change the name of it. Sorry, my type. So let's see whether it works. So yeah, as expected, it is detecting my blue t-shirt also. Let me bring my bag first. Yeah, it is completely able to detect the blue bag. So we are successful in detecting the colored objects in here. So thank you. So next we are going to do motion detection, which is something which is very important in robotics and the field of robotics, using something known as FBGB. So let's learn about it. FBGB stands for foreground background. So what essentially it does is that it separates the foreground and background to take into account which pixels are very useful for us and which would be changing dynamically to detect motion. So it is a machine learning based models where we have some predefined number of frames for the model to learn and decide which is the foreground and which is the background, and it works accordingly. So let us see the implementation in our PC to get more clarity about it. So let's get started. So as you can see, we have written the code for motion detection, and it is supposed to detect even minute changes. So we can change the sensitivity, no doubt, but let me explain it first. So what we are doing, it's like very previous, similar to like object detection or based on color. So we are capturing and like then frame masking, then then we are defining contours and we are printing the rectangle over the detected line. So what is the main change is FBGB, this line. So it is creating a background subtractor with history and threshold as the parameters. So what is history? History is defined as the number of frames you want the machine learning model to take into account to make the model learn about how about what kind of motion you are trying to detect over which background. What threshold is like the pixel sensitivity about which you will be considering when that motion is there. So ideally it is kept at 40, and if and for minute or like motions and all, we will define the a like whether this value is changing. So even for a little bit lip sync lip changes or while I'm speaking, if it's trying to detect, then we have to keep a very sensitive like pixel number. Like for here I've kept 50 for uh, lip detection, and for like hand motion gestures we can just use 5000. So let's see first for 5000 and we'll get into the 51. So as you can see, it is like when I'm static, it is not showing anything. Like I have kept the sensitivity not to detect my lips, so it's not showing even if I like move my lips. But as you see, if I raise my hand, all of the boxes appear. This detects the like there is some motion ongoing on the thing. So why the frame is set to 100. So my MacBook camera has resolution of 1080 and it shoots at 60 fps. So it would be providing the data at 60 fps. So approximately after 1 second and all, it would be the machine would be getting learned, and we would be getting the like background for motion detection. So as you can see, if I raise my hand a little, it will show a big box around it. So let's increase the sensitivity and check how it works. So let's keep the, so ideally it should move my lip, detect my lip movements also. So let's start with like our lips closed. As you can see, even if I move my lips or like head a little, it is showing pretty long, like high number of boxes. Even if my like move my head, it is showing that a little bit, but which was not observable that much in like when we keep the sensitivity high. So it will be very much dynamic depending upon the use case of it. It's showing weird. So it would be very dynamic depending upon the use case, whether you want a very small object to get detected, or like you don't focus on the micro things, you rather focus on the macro things. So it will depend upon what kind of thing you are working with, and that's it. Thank you. Finally learned about everything regarding image processing, and we have also implemented various kind of things like object detection, motion detection. So I feel like we have progressed a lot and we can do more new things. So my task for today's video is that I want you to learn about the model known as CV2.dnn, which is a predefined machine learning model in CV2, which helps you detect what type of object it is using mobile net SSD. I want you to research about it and make a similar kind of object detection model, where you can, if you like place a key on, then it will identify and label it as key. If you place a phone, then it will label it as phone. That is your next task. So we would be, in the next video, we'd be learning about convolutional neural networks and how things are getting learned on how we make images or generate images, generative AI, all of these things we would be learning. So till next, see you.